Linux is the beating heart of modern technology, powerful, versatile, and endlessly fascinating. But let's be real, mastering Linux starts with mastering its commands. In this video, we're diving into 200 Linux commands that will transform the way you work with this incredible operating system. Now, I know what you're thinking. 200 commands? That sounds overwhelming. But don't worry, I've got you covered. This isn't just a list, it's a guided tour. And during the video, you might notice I've used different virtual machines running slightly different Linux distributions. That's intentional, to show you just how adaptable and universal these commands really are. But first, let me give you a few tips on how to get the most out of this video. Option 1. Watch the whole thing from start to finish, pausing after each command to try it out yourself. It's a hands-on approach and perfect for anyone wanting to learn by doing. Option 2. Let the video play and pause whenever something catches your eye. Maybe it's a command you've never seen or an old one used in a new way. This method is great for building on your existing knowledge. Option 3. Relax, grab some snacks, and just watch it like a movie. Let the commands flow, soak it all in, and come back later to try what stands out. To make things even easier, the video is split into 10 sections. And if you ever need a quick reference, I've linked a list of all 200 commands, organized by section, on my GitHub. You can find the link in the description. So, however you decide to watch, whether you're on a mission to learn or just here to marvel at the power of Linux, this video has something for you. Let's dive in and uncover the magic of the Linux command line. Section 1. File and Directory Management. Let's start with the foundation of Linux, file and directory management. This section covers the commands you'll use every day to navigate, organize, and manipulate files and folders. For listing files, moving them, or creating new directories, these commands will feel like second nature by the time we're done. Let's dive in. PWD. The PWD command stands for Print Working Directory. It tells you the exact path of your current location in the directory structure. Think of it as your GPS in Linux, showing where you are in the file system. For example, if you're in the Documents folder, PWD might return something like home username, Daniel in my case, Documents. This command is especially useful when you're working deep in nested directories and need to confirm your current location. ls, it lists the contents of a directory. By default, it shows files and folders in your current directory. Add options like -L for a detailed list view or -A to include hidden files starting with a dot. For instance, ls-al combines both options and shows everything with permissions, sizes, and modification dates. It's the first command you'll use when you want to see what's inside a directory. cd stands for change directory. It's how you navigate through the Linux file system. For example, cd documents takes you into the documents folder, while cd .. moves you up one level. You can also use absolute paths like cd/var/log to jump directly to a specific location. It's a fundamental command for moving around the file system. mkdir, this command is used to create new directories or folders. For example, the command followed by projects creates a directory called projects in your current location. You can also create nested directories in one go with the -p option, like command -p parent/child/grandchild. It's perfect for organizing your files and creating folder structures quickly. rmdir. It removes empty directories. If a directory contains files or subdirectories, you'll need to clear it first or use a different command like rm-r. For example, rmdir old folder deletes old folder only if it's empty. It's a safer way to clean up unused folders without accidentally deleting important content. rm. The rm command is used to delete files or directories. For individual files, just type rm file name. To delete directories and their contents, use rm-r for recursive deletion. If you're absolutely sure and don't want any confirmation prompts, you can use rm-rf, which combines recursive deletion-r with the force option -f. For example, rm-rf folder will delete the folder and all its contents without asking for confirmation. However, be extremely cautious with rm-rf, as it can irreversibly delete critical files or directories if used incorrectly. To avoid accidental deletions, you can use rm-ri for an interactive prompt before each file is deleted. CP. It is for copying files and directories. For example, CP file 1 file 2 creates a duplicate of file 1 named file 2. To copy entire directories, use cp-r, like cp-r source folder destination folder. It's a go-to command for creating backups or duplicating content. mv moves or renames files and directories. For example, mv file 1 folder / moves file 1 into the folder directory. To rename a file, use mv old name new name. This command is efficient for reorganizing or renaming files and folders without creating duplicates. Find. This is a powerful tool for searching files and directories. For example, find/home-namefile.txt searches for file.txt in the /home directory. It supports complex filters like searching by size, -size, or modification time-m time. It's ideal when you need to locate something on a vast file system. Locate. This is another search tool, but it's faster than Find because it uses a pre-built index. For instance, locate file name quickly lists all locations of file name in the file system. Run updated b to refresh the index for accurate results. It's great for quick lookups when you know the name of a file. Touch. The touch command creates empty files or updates timestamps on existing ones. For example, touch newfile.txt creates an empty file named newfile.txt. If the file already exists, it updates its modification date. It's a simple yet versatile tool for creating placeholder files or refreshing timestamps. Tree. Tree displays the directory structure as a tree diagram. For example, running tree in this directory shows all files and folders in a nested format. Add -L to limit the depth, like tree-L2 to display only 2 levels. It's an excellent visual tool for understanding folder hierarchies. Base name. This command extracts the file name from a path. For example, base name /home/test/testfile.txt returns testfile.txt. It's helpful in scripts when you need just the file name without the directory path. Combine it with dir name for more advanced tasks. Dir name, this command complements base name by extracting the directory part of a path. For example, dir name /home-test-testfile.txt returns home-test. It's useful when you want to isolate the folder containing a file for further processing. Real path. It resolves and outputs the absolute path of a file or directory. For example, realpathfile.txt will return home/test/file.txt. It's handy for converting relative paths into absolute ones, especially in scripts where precise paths are essential. Stat. It displays detailed information about a file or directory, such as size, permissions, and timestamps. For example, statfile.txt provides a comprehensive report on file.txt. It's a great tool for debugging file issues or checking metadata. Red link. Red link displays the target of a symbolic link. For example, redlink testfile.txt shows the file the symlink points to. Use it to verify or troubleshoot symlinks in your system. File. It determines the type of a file. For instance, file.txt might return ASCII text. It's useful for identifying unknown files or verifying file types before processing them. ln. This command creates links between files. Use ln original file.txt, hardlink.txt for hard links, or ln-s original file.txt, symbolic link.txt for symbolic links. A hard link is essentially an additional name for an existing file on disk. Both names point to the same inode, meaning changes to one will reflect in the other. However, hard links cannot span across different file systems. A symbolic link or soft link is a pointer that references another file or directory by its path. It can point to files on different file systems, and if the target file is deleted, the symbolic link becomes broken or dangling. Alias. It lets you create shortcuts for commands. For example, alias ll equals ls-la makes ll run ls-la. Use alias to save time and simplify frequently used commands. Add them to your .bash rc for permanent shortcuts. Use alias to list the current shortcuts. Section 2. Viewing and editing files. Now that you can navigate the file system, it's time to learn how to view and edit files. This section includes commands for inspecting file contents, editing text files, and working with data directly from the command line. For analyzing logs or tweaking configuration files, this is where the real magic happens. Cat. The cat command stands for concatenate and is used to display the contents of a file or combine multiple files. For example, catfile.txt prints the content of file to the terminal. You can also use catfile one file 2 greater than combined.txt to merge file 1 and file 2 into a single file named combined.txt. It's a quick and straightforward way to read files or combine them. Less. This command is a pager program used to view large files one screen at a time. Unlike cat, it doesn't dump the entire file at once. For example, lessfile.txt allows you to scroll through file.txt using the arrow keys. It's great for reading logs or lengthy documents. Press Q to exit the viewer. More. It is similar to less, but with fewer features. It displays files page by page, making it suitable for reading large files. For example, morefile.txt lets you view file.txt one screen at a time. Use the spacebar to scroll down. However, less is generally preferred for its additional navigation options. Head. This command shows the first few lines of a file. By default, 10 lines. For example, headfile.txt displays the first 10 lines of the file. You can customize the number of lines with the n option, like head-n5file.txt. It's useful for quickly previewing the start of a file. Tail. It displays the last few lines of a file, also defaulting to 10 lines. For example, tailfile.txt shows the last 10 lines of file.txt. Use the F option, like tailf sizelog, to monitor a file in real time as it's updated. This is particularly useful for watching logs in a live system. Nano. It is a simple, user-friendly text editor available in most Linux distributions. For example, nanofile.txt opens the file for editing. Use basic keyboard shortcuts like Ctrl-O to save and Ctrl-X to exit. It's a great choice for quick edits, especially for beginners. Vim. It's a powerful text editor with a steep learning curve but immense capabilities. For example, vimfile.txt opens the file in Vim. You start in command mode, where you can navigate and issue commands, and switch to insert mode by pressing I to edit text, save and exit with :WQ. It's ideal for advanced users who want precise control. Gedit. It is a graphical text editor for the GNOME desktop environment. For example, geditfile.txt opens the file in a user-friendly interface. It supports features like syntax highlighting and plugins. It's a solid choice for those who prefer GUI over terminal-based editors. Emacs. This is a highly customizable text editor that's also an entire computing environment. For example, emacsfile.txt opens the file. You can extend its functionality with custom scripts and plugins. Though complex, it's favored by users who want a versatile tool for coding, writing, and more. Echo. This command prints text or variables to the terminal. For example, echo hello world displays hello world on the screen. It's also used in scripts to output messages or values. You can redirect the output to a file like echo sample text greater than file.txt. It's simple but incredibly versatile. WC. WC stands for word count and provides counts of lines, words, and characters in a file. For example, wcfile.txt shows the number of lines, words, and bytes in the file. Use options like -L for lines or -W for words only. It's great for analyzing file content. Cut. Cut extracts specific sections of text from a file. For example, we have this users.csv file. To get just the usernames from the file, we can use the cut command with these options, where -D specifies the delimiter, in this case a comma, and -F1 indicates that you want to extract the first field. We get an output of the usernames. If we want to extract emails, we adjust the command to use -F2. This command is perfect for parsing and working with structured data like CSVs. Split. It divides a large file into smaller chunks. For example, split-L100 file.txt splits file into smaller files, each containing 100 lines. It's useful for breaking down large files for processing or sharing. CMP. It compares two files byte by byte. For example, CMP file 1 file 2 checks if file 1 and file 2 are identical. If they differ, it shows the location of the first mismatch. It's great for verifying file integrity. DIFF. It compares two files line by line and highlights their differences. For example, diff file 1 file 2 shows the lines that differ between the two files. It's invaluable for code reviews or tracking changes in text files. Patch. It applies changes to a file based on a diff file. For example, patch changes.diff updates the target file using the instructions in changes.diff. It's often used in collaborative development to apply updates or fixes. Sort. It arranges the lines in a file in ascending or descending order. For example, sortFile.txt sorts the lines alphabetically, while sort-n sorts numerically. It's a handy tool for organizing data or preparing lists. Unique. It removes duplicate lines from sorted input. For example, sortFile.txt pipeUnique sorts the file and removes duplicates. Use it with -c to count occurrences of each line. It's great for summarizing and cleaning data. TR. It translates or deletes characters in text. For example, echo hello with this TR option converts lowercase letters to uppercase. Use TR-D to delete specific characters. It's a powerful tool for text transformation. SED. It's a stream editor used for text manipulation. For example, SED's old new GG file.txt replaces all occurrences of old with new in the file. It supports complex text processing tasks like pattern matching and replacement. It's a go-to command for automation and scripting. Section 3. Permissions and ownership. Security is critical in any operating system, and Linux is no exception. In this section, we'll dive into permissions and ownership. You'll learn how to manage access to files and directories, assign ownership, and understand how Linux keeps your system secure. Let's unlock the secrets of permissions. chmod. This command changes file or directory permissions. In Linux, permissions are represented by read R, write W, and execute X for three entities: owner, group, and others. For example, chmod 755file.txt sets read, write and execute permissions for the owner, and read and execute for group and others. Use symbolic notation like chmodu plus xfile.txt to add execute permission for the user. It's a critical tool for controlling file access, so use it wisely. chown. This command changes the owner of a file or directory. For example, chown userfile.txt changes the owner of file.txt to user. To also change the group, use chown user::group_file.txt. Recursive ownership changes can be made with -r, like chown-r user::group/directory. It's often used by administrators to manage ownership of shared resources. chgrp. This changes the group ownership of a file or directory. For example, chgrp group file.txt assigns file.txt to the specified group. Combine it with -r for recursive changes like -r group/directory. While similar to chown, it's specifically used for group management. umask. This command sets the default permission mask for new files and directories. For example, a umask of 022 results in files with permission 644 and directories with 755. Use umask to ensure new files and directories have appropriate permissions by default. To view your current umask, just type it without arguments. ls. It lists files and directories in a detailed long format. It displays information like permissions, number of links, owner, group, file size, and modification date. This output shows the permissions, owner, group, size in bytes, and timestamp. It's essential for reviewing file details. ID. It displays user and group IDs for the current or specified user. For example, ID shows your user ID UID, group ID GID, and any additional group memberships. Use ID followed by a username to view details for that user. It's great for checking permissions and roles. Groups. This command lists the groups a user belongs to. For example, just typing groups shows your group memberships, while groups followed by a username displays them for that user. It's helpful for verifying group access permissions. Who am I? It simply returns the username of the currently logged in user. For example, if you're logged in as root, it will display root. It's useful for confirming your current identity, especially when switching between users with sudo or su. Sudo. This allows a permitted user to execute a command as another user, typically root. For example, sudo apt update runs the apt update command with root privileges. It's a safer alternative to logging in as root directly because actions are logged. Use sudo-i for a temporary root shell or sudo-u user command to run a command as another user. Su. Using this command switches to another user account, typically root. For example, su without arguments switches to the root user, while su-username switches to username with their environment variables loaded. Unlike sudo, su requires the target user's password, making it more direct but less restrictive in some setups. Section 4. System Monitoring and Processes. Linux is known for its powerful system monitoring capabilities, and this section is all about keeping an eye on what's happening under the hood. From viewing system performance to managing running processes, these commands will help you understand and control your system's behavior. Let's take a closer look. Top. It provides a real-time dynamic view of system processes, resource usage, and performance metrics. It shows CPU, memory usage, process IDs, and other details. Use it to monitor and manage system performance. Press Q to exit or type man-top for more options. HTOP. It's an interactive process viewer similar to Top but more user-friendly. It features a colorful interface, supports mouse interaction, and allows easier process management, such as killing processes directly by pressing F9. Install it if not already available with sudo apt install htop. PS. This command lists processes running on the system. For a snapshot of your current session, use PS. For all processes, use PS-E. Combine it with options like PSAUX to see detailed information about all processes, including their memory and CPU usage. Kill. It sends a signal to terminate a specific process by its process ID. For example, kill 1234 ends the process with PID 1234. Use kill-9 1234 for a forceful termination. Always check the process details with PS or top before using it. Kill all. It terminates processes by their name instead of PID. For example, kill all Firefox kills all instances of Firefox. Use it with caution to avoid stopping critical processes. Add -9 for forceful termination, like kill all -9 Firefox. pkill. This works like kill all but supports pattern matching. For example, pkill-9 Apache terminates all processes matching Apache. It's a more flexible alternative to kill all and is great for managing multiple processes. Jobs. This command lists background jobs in the current shell session. For example, if you run a command with ampersand, it becomes a background job. Use jobs to see their status. FG. It brings a background job to the foreground. For example, if you have a background job with a specific ID, type FG% and that ID to bring it to the foreground. It's helpful for resuming paused tasks. BG. It resumes a paused job and runs it in the background. For example, if a job is stopped, use BG%1 to continue it in the background. Combine it with jobs to manage active tasks effectively. Nice. This command starts a process with a specified priority. Lower values mean higher priority. For example, nice and 10 myscript.sh starts the script with a priority of 10. Use it to manage resource allocation for non-critical tasks. Renice. It changes the priority of an existing process. For example, renice n5 p1234 sets a priority of 5 for the process with PID 1234. Combine it with PS or top to adjust priorities dynamically. Uptime. This command displays how long the system has been running, along with load averages for the past 1, 5, and 15 minutes. Free. It shows memory usage, including total, used, free, and available memory. Use free-h for a human-readable format. It's helpful for monitoring RAM utilization at a glance. DF. It reports disk space usage by file system. For example, df-h displays sizes in human-readable formats like GB or MB. Use it to check available space on mounted partitions. DU. It estimates disk usage of files and directories. For example, du-h followed by folder name shows the size of the folder and its contents. Add -d for depth control, like do -h-d1 to limit output to top-level directories. IO-stat. This command provides detailed input-output statistics for disks and CPUs. Use it to analyze performance bottlenecks. For example, IO-stat-x includes extended statistics like utilization percentages. VM-stat. It reports on system performance metrics like CPU, memory, and I/O usage. For example, VM-stat25 samples data every 2 seconds for 5 iterations. It's a lightweight tool for performance analysis. SAR. It collects reports and saves system activity data. Use SR-U for CPU usage or SR-R for memory. It's part of the sysstat package, offering advanced performance monitoring over time. Watch. It runs a command repeatedly at regular intervals. For example, watch N5DF H displays disk usage every 5 seconds. Use it to monitor changes in real time. Time. It measures how long a command takes to execute. For example, time ls reports the real user and system time taken by the ls command. It's great for analyzing script performance. Section 5. Networking commands. Linux excels in networking, making it a favorite for servers and developers alike. In this section, we'll explore commands for checking network configurations, diagnosing issues, and testing connectivity. For your setting up a server or troubleshooting a connection, these tools are indispensable. Ping, it checks network connectivity and measures latency to a host. For example, pinggoogle.com sends ICMP packets to Google's server and shows response times. It's great for testing if a server or network is reachable. Curl. It transfers data from or to a server using various protocols like HTTP, HTTPS, or FTP. For example, curlgoogle.com fetches a web page. Use curl-o to download files, if it has files available for download, or curl-I to fetch HTTP headers. wget, it's a command line tool for downloading files. For example, wget followed by this URL saves the file locally. Use wget-r to download entire websites recursively. It's especially useful for automating downloads. ifconfig. It displays or configures network interfaces. For example, ifconfig WLO1 shows details of the wireless network interface. While it's becoming outdated, it's still used in some Linux distributions for basic network configuration. IP. It's a modern alternative to ifconfig. For example, IPAddr shows all network interfaces and their IP addresses, and IP-link manages network devices. It's more powerful and widely used in modern systems. Netstat. It displays network connections, routing tables, and interface statistics. For example, netstat-tuln shows all listening ports. Though deprecated in favor of SS, it's still useful in legacy systems. SS. It's a faster alternative to netstat for displaying socket statistics. For example, ssTuln lists all listening ports with less overhead. It's the go-to tool for analyzing network connections on modern Linux systems. NSLOOKUP. It queries DNS records for a domain name. For example, nslookupgoogle.com fetches its IP address. Use it to troubleshoot DNS-related issues like domain resolution errors. Dig, it is a more advanced DNS query tool than NSLOOKUP. For example, diggoogle.com retrieves DNS records, while digmxgoogle.com fetches mail server information. It's widely used by network administrators. Traceroute. It maps the path packets take to reach a destination. For example, traceroute.google.com shows each hop along the way, helping diagnose network latency or routing issues. Route. It displays or modifies the system's routing table. For example, route-n shows network routes without DNS resolution. While often replaced by IP route, it's still useful for basic routing configurations. ARP. It displays or modifies the ARP, Address Resolution Protocol table, which maps IP addresses to MAC addresses. For example, ARP-A shows all entries. Use it to diagnose local network issues. TCP dump. It captures and analyzes network packets. For example, TCP dump-I001 captures packets on the 001 interface. Use it with filters like TCP dump port 80 to narrow down traffic to specific protocols or ports. Nmap. It is a network scanning tool for discovering hosts, services, and open ports. For example, Nmap followed by an IP or a domain scans a specific host, while Nmap-P 22-8192.168.1.0/24 scans a subnet for open ports. SCP. It securely copies files between systems over SSH. For example, scpfile.txt followed by user at remote host : and path copies a file to a remote machine. Use scp-r to copy directories recursively. It's simple and reliable for secure file transfers. rsync. It synchronizes files and directories between systems or within a system. For example, rsync-avsource/destination/copies files while preserving permissions. It's efficient for large or incremental file transfers. FTP. It connects to FTP servers for file transfers. For example, ftp-ftp.dlptest.com logs into a server. Use put to upload files and get to download them. While less secure than SFTP, it's still used in some cases. SFTP. It stands for Secure File Transfer Protocol and is an interactive file transfer program similar to FTP, but encrypted via SSH. It can be used SFTP user at remote address, and it connects to the remote server. US it's safer than FTP and ideal for secure file transfers. Telnet. It establishes a raw text-based connection to a server. For example, Telnet follow by this domain connects to a web server on port 80. It's mainly used for testing and troubleshooting, though it lacks encryption. SSH. It provides secure remote access to another machine. For example, SSH user at server IP logs into the remote system. Add options like -I for key-based authentication or -P to specify a port. It's essential for managing Linux servers. Section 6. Package Management. Software management is a breeze with Linux package managers. In this section, we'll cover commands to install, update, and remove software across various distributions. From daily tools to critical libraries, you'll learn how to keep your system updated and running smoothly. apt-get. It's a command line tool for managing packages in Debian-based systems. Use apt-get update to refresh the package list, apt-get install follow by the package name to install it, or apt-get remove package name to uninstall it. For upgrading the system, run apt-get upgrade. It's a reliable way to handle your system's software needs. apt. It's a more user-friendly version of apt-get. For example, apt-install replaces apt-get install, but with additional feedback and progress bars. It's designed to simplify package management without sacrificing functionality. Use it for day-to-day tasks like installing, upgrading, and searching for packages. Yum, or Yellow Dog Updater Modified, is used in RPM-based distributions like CentOS. Run yum install package name to add software, or yum update to upgrade the system. It supports automatic dependency resolution, making it a staple for Red Hat-based systems. DNF. It's the successor to yum introduced in Fedora. It offers better performance and fewer bugs. Use commands like dnf install package name or dnf remove package name for package management. It's faster and more efficient than yum while maintaining backward compatibility. Pacman. It's the package manager for Arch Linux and its derivatives. Use pacman-s package name to install software, or pacman-r package name to remove it. For updating the system, run pacman-syu. It's known for its speed and simplicity, much like Arch itself. Snap. It's a package management system designed by Canonical. It allows you to install software in a self-contained format. Run snap install package name to install a snap package. It works across distributions and eliminates dependency conflicts, making it great for modern app delivery. Flatpak. It's a universal package manager designed for sandboxed applications. Use Flatpak install remote package name to add a package, or Flatpak run package name to execute it. It focuses on application isolation, making it secure and versatile across Linux distributions. RPM. It's the package manager for Red Hat-based systems. Use rpm-i package.rpm to install an RPM file or rpm-epackage-name to remove it. You can also verify package integrity with rpm-v package name. It's a low-level tool that works alongside yum and dnf. dpkg. It's the Debian package manager. Use dpkg-ipackage.deb to install .deb files or dpkg-rpackage name to remove software. It's the backbone of package management in Debian-based systems, often used under the hood by tools like apt-get. Brew or Homebrew is a package manager for macOS and Linux. It simplifies software installation with commands like brew install package name. Use brew update to refresh the repository and brew upgrade to update installed packages. It's especially popular among developers for its simplicity and extensive library of tools. Section 7. Disk and storage management. Managing disk space and storage is a key part of Linux system administration. This section dives into commands for checking disk usage, managing partitions, and working with file systems. For performance optimizing or troubleshooting issues, these commands have you covered. Mount. It's used to attach a file system to a specified directory in Linux. For example, mount dev/sdx1 mnt mounts a partition to mnt. It's essential for accessing drives, partitions, and external storage. Add options like -oro to mount read-only. umount. It detaches a file system. To unmount a partition, use umount/mnt or specify the device, like umount/dev/sdx1. Make sure no files or processes are using the mounted directory or the unmount will fail. blkid. This command lists block devices and their attributes, such as UUIDs and file system types. Use it to identify partitions. blkid/dev/sdx1 shows detailed information about a specific partition. lsblock. It provides a tree view of all block devices, including their mount points and sizes. Run lsblk to quickly understand how storage is structured on your system. It's especially useful when working with multiple drives. df. It displays disk space usage for mounted file systems. Run df-h to see human-readable sizes for each mount point, helping you monitor free and use space on your storage devices. du. It estimates file and directory space usage. Use du-sh folder name for a summary of a folder's size. It's a great way to identify large directories consuming space on your system. fdisk. It's a command line tool for partitioning drives. Use it to create, delete, or modify partitions. For example, fdisk/dev/sdx lets you interactively manage partitions on a disk. Parted. It's a more modern alternative to fdisk with support for GPT and larger drives. Run parted/dev/sdx to start and use commands like mklabel GPT to initialize a drive or mkpart to create partitions. mkfs. It creates a file system on a partition. For example, mkfs.ext4/dev/sdx1 formats a partition as ext4. Be careful, as it erases all existing data on the partition. fsck. It checks and repairs file systems. Run fsck/dev/sdx1 to scan a partition for errors. Use it with care, especially on mounted file systems, as it can cause data corruption if mishandled. tune2fs. It adjusts x2, x3, x4 file system parameters. For example, tune2fs-c50/dev/sdx1 sets the maximum mount count before a check is forced. It's great for optimizing or tweaking file system behavior. resize2fs. It resizes x2, x3, x4 file systems. For instance, resize2fs/dev/sd x120 gigabytes shrinks or grows the file system to 20 gigabytes. Ensure the partition is adjusted before resizing to avoid errors. E2FSCK. It checks and repairs X2, X3, X4 file systems. It's similar to FSCK but specialized for X-based systems. Use E2FSCK-fdev/SDX1 to force a file system check. LSATTR. This command lists file and directory attributes on X file systems. For example, LSATR followed by the file name shows special attributes like whether a file is immutable. It's useful for troubleshooting file permissions. ChetTR. It modifies file attributes on X file systems. For example, ChetTR plus I followed by the file name makes the file immutable, meaning it cannot be modified or deleted even by root. XFS check. It verifies the integrity of XFS file systems. Run it as XFS check/dev/SDX1 to look for errors. Note that the file system must be unmounted to use this tool. XFS repair. It fixes issues in XFS file systems. Use it like XFS repair/devi/SDX1 to resolve corruption. As with XFS check, ensure the file system is unmounted before running this command. BTRFS. It's a command suite for managing BTRFS file systems. It handles tasks like creating snapshots, checking status, and balancing storage. BTRFS is known for its advanced features like compression and RAID. Swap off. It disables swap space. For example, swap off dev/SDX2 turns off a specific swap partition. It's often used during system maintenance or resizing of swap areas. Swap on. It enables swap space. Run swap on dev/SDX2 to activate a swap partition or file. Combine it with swap on S to view all active swap areas and their usage. Section 8. Archiving and compression. Need to save space or share files efficiently? This section is all about archiving and compression. We'll cover commands to create, extract, and manage archives in formats like tar, zip, and gzip. These tools are essential for working with backups, deployments, and large data transfers. TAR. It archives files without compression by default. Use tar-cv farchive.tar files to create an archive and tar-xvf archive.tar to extract it. Add -z or -j for gzip or bzip2 compression. Zip. It creates compressed archives. For example, ziparchive.zip files compresses files into a .zip archive. Use -r to include directories recursively. Zip-r archive.zip folder /. Unzip. It extracts zip archives. Run unziparchive.zip to extract all contents. Use options like -l to list the files inside the archive without extracting them. Gzip. It compresses files. For example, gzip file creates file.gz. Use it with -k to keep the original file intact. Gzip-k file quote. Gunzip. It decompresses .gz files. For instance, gunzipfile.gz restores the original file. Combine with -k to keep the compressed file. Gunzip-k file.gz. bzip2. It compresses files with better compression ratios than gzip. Use bzip2 file to create file.bz2. Add -k to preserve the original file. bzip2-k file. bunzip2. It decompresses .bz2 files. Run bunzip2 file.bz2 to extract the original file. Add k to retain the compressed file. bunzip2-k file.bz2. xz. It compresses files with high efficiency. Use xz file to create file.xz. To retain the original file, include -k, xz-k file. unxz. It decompresses .xz files. Run unxz file.xz to restore the original file. Add k to keep the compressed file. nxz-k file.xz. 7z. It creates and extracts .7z archives. Use 7za archive.7z files to create an archive and 7zx archive.7z to extract its contents. It supports high compression ratio. P7z IP. It's a Linux port of the 7z command. It provides similar functionality to compress and extract archives, including .7z and others. RAR. It creates RAR archives. Use rar archive.rar files to compress files into a .rar archive. This command is proprietary and may require installation. UNRAR. It extracts .rar archives. Use it with X flag to extract contents or with an L flag to list the files inside. Like the previous command, this may also need installation. AR. It creates and manages .ar archives, commonly used in Debian package files. For example, AR archive.r files adds files to an archive, and ARX archive.r extracts them. CPIO. It creates or extracts archives, often used with piping. For example, this command will create an archive and then extracts it. Zcat. It views compressed.gz files without extracting them. Use zcat file.gz to print its content. It's like cat but for compressed files. Zles. It lets you view .gz files with pagination, just like less. Run zlesfile.gz to navigate through the file's content without extracting it. LZMA. It compresses files into .lzma format. Use lzma file to create file.lzma. Add k to retain the original file, lzma k file. xzcat. It is similar to zcat but for .xz files. Use xzcat file.xz to print the file's content without extracting it. tar-zxvf. It extracts .tar.gz archives. For example, tar zxvf archive.tar.gz decompresses and extracts the archive in one step. The options mean Z for gzip, X for extract, V for verbose, and F for specifying the file. Section 9. User Management. Linux is a multi-user operating system, and managing users is a vital skill. In this section, we'll explore commands to add, modify, and delete users and groups. You'll also learn how to manage passwords and control user access. Let's dive into the human side of Linux administration. Add user. It's a user-friendly command to add new users. It creates the user's home directory and prompts for details like username, password, and user information. It can be used like add user followed by the username you want to create. User add. It is a lower-level command for adding users. It requires explicit options to set up home directories and passwords. Example, sudo user add ms/bin/bash username creates a user with a home directory and bash shell. User mod, it modifies user accounts. Common uses include changing a username or adding a user to a group. For example, to change username sudo usermod-l new name old name, or to a group sudo usermod-a group name username. Del user. It removes users. It can also delete their home directory with the --remove home flag. To delete the home directory, use it with the flag --remove home username. Userdel, it deletes user accounts at a lower level than deluser. It does not delete the user's home directory unless -r is used. It can be used with userdel-r followed by the username. Passwd. It changes a user's password. Users can change their password by running it directly, while administrators can set passwords for others with the command followed by the username. Group add. It creates a new group, for example, group add followed by the group name. Group mod. It modifies group properties. You can rename a group using the command -n new group name followed by the old group name. Group del. This command deletes a group. Use caution, as it can break permissions for files owned by that group. ID. It displays the user ID, UID, group ID, GID, and group memberships of the specified user or the current user if no username is provided. Use ID username to view another user's information or simply ID for the current user. Who? It shows details about currently logged in users, including their usernames, terminals, and login times. Run Who to get a simple list of active sessions. It's useful for monitoring multi-user systems. W. It provides a more detailed overview of system activity and logged in users. It shows who is logged in, what they're doing, idle times, and system load averages. Simply run W to view real-time user and system information. Finger. It retrieves detailed information about a user, such as login time, home directory, shell, and other metadata. Use Finger username for specific user details, or Finger for all available users on the system. Last, it displays the login history of users, including their login times, durations, and logout times. Run last to see recent logins or last username for a specific user's history. It also logs reboots and shutdowns. Login. This command initiates a new user session by prompting for a username and password. Typically used in text mode environments to start a session, it's rarely invoked directly by end users on modern systems. Logout. It ends the current session for the logged in user. It's commonly used in terminal environments. Simply type logout to safely close your shell session. Who am I? It prints the username of the current user. It's a quick way to verify which account you're operating under. Simply run Who am I to display your active user. Sudo. It allows users to run commands with root privileges. Prepend sudo to a command, like sudo apt-update, to execute it as a super user. Use sudo-i to start a root shell session. SU. It switches the current user to another account. Use SU username to log in as another user or su- to switch to the root account with the root user's environment settings. vsudo. It safely edits the sudoers file, ensuring syntax correctness and avoiding potential lockouts. Use sudo vsudo to grant or revoke sudo privileges for users or groups, like adding username, or to allow passwordless sudo access. Section 10. Miscellaneous useful commands. Finally, we'll wrap things up with a collection of miscellaneous but incredibly useful commands. From troubleshooting tools to text processing and quick utilities, this section is packed with tips and tricks to make your Linux experience even more powerful. Let's close with a bang. Man. It displays the manual pages for Linux commands and applications. Use man command to learn about the command, its options, and usage examples. For instance, man ls opens the manual for the ls command. Press Q to exit the manual viewer. Alias. It creates shortcuts for long or frequently used commands. For example, alias ls. lf creates an alias l for listing detailed directory contents. To remove an alias, use unalias alias name. Use alias with no arguments to list all current aliases. History. It shows a list of previously executed commands in the terminal. Run history to view the list or use exclamation point number to repeat a specific command, for example. Exclamation point 22 reruns, command number 22, and so on. Combine it with grep for searching commands like history pipe grep keyword. Clear. It clears the terminal screen, making it easier to focus on new commands. While it doesn't delete history, it visually resets the terminal for a cleaner workspace. Just type clear and hit enter. Date. It displays or sets the system date and time. Use date to see the current date and time, or customize the output with format options, like date plus year, month, day, hour, minute, second. To set the date, root required, use date-s followed by the date and time. Cal. It displays a simple calendar in the terminal. Running cal shows the current month, while cal followed by year displays the calendar for a specific year. Use cal month year to view a specific month of a given year, like cal 12/20/24. Uptime. This command shows how long the system has been running, the number of logged in users, and the system's average load over the past 1, 5, and 15 minutes. Simply run uptime for a quick system health summary. Uname it displays basic information about the system. Use uname-a to see all details including the kernel name, version, architecture, and operating system. It's especially helpful for verifying system environments. Hostname. It displays or sets the system's network hostname. Running hostname shows the current hostname, while hostname new name requires root changes it. Use hostname.ctl for more advanced hostname management. BC. It is an interactive command line calculator supporting basic and advanced arithmetic operations. Enter BC to start, then type calculations like 5 plus 5. Use scale equal n to define the number of decimal places. Exit with Ctrl plus D. XPR. It evaluates expressions, often for arithmetic or string operations. Use XPR 5 plus 3 for addition or XPR index hello E to find the position of a character. Quoting expressions prevents issues with special characters. SEQ. It generates a sequence of numbers. For example, SEQ110 lists numbers 1 through 10. Use SEQ start step end for custom increments, like SEQ1210 to count by twos. It's useful in scripts and loops. Yes. It outputs a string repeatedly until interrupted. Run yes to output y endlessly or yes no for custom text. It's handy for automating prompts but must be stopped with Ctrl-C. Sleep. It pauses execution for a specified amount of time. Use sleep n to pause for n seconds or sleep 1 minute for 1 minute. Combine it in scripts to delay processes or manage timing. Shutdown. This command powers off or restarts the system safely. Use shutdown now to turn off immediately, shutdown R now to reboot, or shutdown plus 10 to power off after 10 minutes. Use shutdown-C to cancel a pending shutdown. Reboot. This command restarts the system immediately. Use reboot to safely restart or combine it with options like reboot force to bypass certain checks. It's equivalent to shutdown R now. Power off. It shuts down the system immediately. It's similar to shutdown now, but directly instructs the system to turn off power. Use with caution on production environments to avoid data loss. Systemctl. It manages system services. Use it to start a service, to stop a service, or to check a service status. It also handles system states, like systemctl reboot or systemctl power off. Journalctl. It displays logs managed by systemd. Use it to view all the logs or just for a specific service. Combine with -f to follow live logs or /since for time-based queries. DMESG. It prints kernel messages typically related to hardware and system boot. Run it to view all messages or use it with grep followed by a keyword to filter for specific events like errors. It's valuable for troubleshooting system issues. env. It displays the current environment variables or runs a command in a modified environment. Use env to view all variables or env var equal value command to temporarily set a variable for a command. Export. It sets environment variables that persist for the current session and any child processes. For example, export var equal value makes var available to scripts or commands run in the same session. To unset a variable, use unset var. Print environment. It displays the value of specific environment variables. Run printenv to list all variables or printenv var to see the value of var. It's often used to check variable settings like printenv path. Set. It displays or modifies shell options and variables. Running set without arguments lists all variables and functions. Use it with options like set-e to stop a script on errors or set +x to disable debugging output in scripts. Unset. It removes shell variables or functions. For example, unset var deletes the environment variable var, and unset-f function name removes a function. Be cautious when unsetting essential variables like path. Declare. It defines variables or functions with specific attributes in bash. Use declare-evar to make var an integer, declare-r var to make it read-only, or declare -a array to define an array. Running declare lists all defined variables. Type. It identifies how a command is interpreted. Use type command to check if it's a built-in, alias, or external command. For instance, type ls might show ls is alias to lscolorAuto if an alias exists. Which. It locates the executable path of a command in the system's path. For example, which Python shows the full path of the Python binary, such as /userbin/python. It's helpful for verifying which version of a tool is being used. Where is. It searches for the location of a binary, its source code, and its manual pages. It's broader than which but less customizable. Apropos. It searches manual pages for a keyword. For instance, apropos network lists all commands and descriptions related to networking. It's useful for discovering commands or utilities for specific tasks. What is? This command provides a brief description of a command. For example, what is ls will return list directory contents. It's quicker than reading full manual pages for understanding a command's purpose. Locate. It quickly searches for files using a pre-built index. Run locate followed by the file name to find all occurrences of file in the system. Unlike find, it doesn't search the file system in real time, making it much faster. Update DB. This command updates the database used by locate. Run it as root to ensure locate has an up-to-date index of files. For example, after creating new files, run sudo updatedb so locate can find them. Xargis. It builds and executes command lines from standard input. For example, this command deletes all txt files found by find. It's useful for chaining commands that process multiple arguments. T. It reads from standard input and writes to both standard output and a file. Use command pipe t file to display the output while saving it to a file. Add a -a to append to the file instead of overwriting it. grep. It searches for patterns in files or input. For example, grep error log.txt finds all lines containing error in log.txt. Use options like -i for case-insensitive search or -r to search recursively in directories. AWK. It is a powerful text processing tool. Use it to manipulate and analyze data from files or input. For example, AWK print $1 followed by the file name prints the first column of each line. It supports pattern matching and advanced scripting. Sed. It's a stream editor for modifying text in files or input. Use sedes, old, new, followed by the file name to replace the first occurrence of old with new in each line. Combine with -i to edit files in place. Cut. It extracts specific fields or characters from a file or input. For example, this command extracts the first column from a CSV file. Use -c to select specific character ranges. NoHop. It allows you to run a command immune to hangups, so it continues running even if you log out. Use it like nohop followed by the command to execute it in the background. The output is typically saved to a file called nohop.out. It's invaluable for running long processes without interruption. Congratulations on making it to the end. Completing this journey is no small achievement. It shows your dedication to mastering Linux and expanding your skills. You've proven you're on the path to becoming a truly confident and capable Linux user. Before you go, I want to hear from you. Which command did you find the most interesting or useful? Was there one that surprised you or changed the way you work? Leave a comment below and let me know. Thank you for watching. Check out my other videos and see you next time.